Okay, this is Algebra 2, and we're moving on to 5-9. And this says fractional equations. Let me just read the opening paragraph. An equation such as 1 plus the quantity 12 over x squared minus 4 equals the quantity 3 over x minus 2, in which a variable appears in the denominator of a fraction is called a fractional equation. Transforming a fractional equation by multiplying each of its members by the least common denominator of the terms may not produce an equivalent equation. So, arg, now we've got a problem, don't we? This is an issue. So they show in example 1, working the equation that they gave. I mean, example 1, 5-9. This is page 170, by the way, 178. Or it's possibly page 184. Okay? Okay. Sorry, just looking at some teacher notes there. So we're either on page 184 or you're on page 178. All right, so when you look at example 1, they identify the least common denominator as x squared minus 4. And they multiply each side of the equal sign by x squared minus 4. And that leaves them with x squared minus 4 plus 12, which equals 3 times the quantity x plus 2. And that all combines to x squared minus 3x plus 2 equals 0. So now we have x minus 2, factor x minus 2 times factor x minus 1 equals 0. And x equals 2, x equals 1. But now we need to run a test to see if those work. It turns out that 2 doesn't work, and the reason 2 doesn't work is that if you put it back into the original equation, it gives 0 in the denominator, and we can't have 0 in the denominator. And x equals 1, that does work. So what they're telling you is that when you have variables in the denominator, you have to be concerned about the possibility that you will end up with rogue answers, solutions that don't satisfy. And that's because when you use the strategy of multiplying by a common denominator, you can end up with an equation that is not truly equivalent. Now, one thing that's always helpful to do with these types of problems where you have a variable in the denominator when you start, one of the things to think about doing, is even before you begin to identify what values are not allowed, right? So if you look at the example 1, the 1 plus 12 over x squared minus 4 equals 3 over x minus 2, that 3 over x minus 2, right away you should be able to recognize, well, 2 is not going to be allowed as a solution. And then you would notice that it's the same thing for 12 over x squared minus 4. 2 is not allowed as a solution there either. So by doing that, you can help yourself think about, keep in mind that this is a situation where it's possible that there are solutions that are not allowed. Okay? The gray box at the bottom, page 178, says when you transform an equation by multiplying by a polynomial, always test each root of the resulting equation in the original equation. Well, those values producing true statements belong to the solution set of the original equation. All right. Now, on page 179 or page 185, the two examples there are word problem examples. You're going to want to read through those. I'm not going to worry about those right now. Let's go to the written exercises. In fact, let's get down the assignment. Okay, so if you're looking at the written exercises for 5-9 on page 186, this will be your assignment. On 186, you're going to do 1, 5, 9, 11. On 187, you will do 1 through 7 odd. On 181, you'll do number 2, and on 182, you'll do number 14. Okay, now the page numbers, if you're looking at the written exercises for 5-9 and they're page 180, this would be page 180. The 1 through 7 odd would be page 181. Number 2 you will do on page 175. And number 14 you'll find on 176. Okay, so there's the different page numbers. Okay, let's go ahead and look at a few of these. Let's look at number 1 on page 180 or 186. 1 over x plus 1 over 2x equals 1 over 6. Okay, so what can we do here? Well, the first thing is, what I would suggest is to realize that x can't equal 0. Right, so I'm going to put over here x not equal to 0. Okay, so what do we do? Well, I guess we're supposed to multiply by the least common denominator, or at least a common denominator. I think we can multiply everything by 6x. Okay, because the number parts, 6 would be the least common, and the letter parts, x would be the least common. So if I multiply the first fraction by 6x, I get 6. If I multiply the second fraction by 6x, I get 3. If I multiply this 1/6 by 6x, I get x, which tells me x equals 9. And that's good. And you can plug the 9 into the original equation, and I think you're going to find that it works. So that's pretty straightforward, right? So on number 5, you want to do something similar. Remember that if you can't find the least common denominator, you can at least multiply by a common denominator, and that the common denominator would be the given denominators multiplied together, and that will work too. So Your responsibility for the written exercises for 5-9 is 1, 5, 9, 11. Don't hesitate to factor any single denominator to see its factors to help you build your common denominator. Again, while it's going to be most convenient if you find the least common denominator, as long as you use a common denominator. So for example, on number 9, you could simply multiply s plus 1, or say that you're multiplying s plus 1 times s times the quantity s squared plus s. All three of those denominators multiplied together. That will be a common denominator. It may not be the least common denominator. All right, I'll quit hammering that. Okay, so hopefully that settles you for this, right? So the working with fractions here is not any different than what you've done before. Still multiplying the whole equation by a common denominator. The difference is because your variables are in the denominator to start with, you have to worry about actually checking your answer to make sure it's a legitimate solution. Okay, on the next page, either page 181 or page 187, the problems there, you're doing 1, 3, 5, and 7. And I think I'm just going to leave those for you to do. I mean, I think the only possibility here is that you end up with variables in the denominator. I think we will look at number 7. Let's look at number 7. This is number 7 on either page 181 or 187. It says two numbers are in the ratio 6 to 11. If the first number is decreased by 4 and the second increased by 6, the resulting numbers are in the ratio 4 to 9. Find the original numbers, right? So, you know, you might think, oh, that sounds a little bit hard. Well, let's think about our process. What's the first thing we do? Well, what are they asking us to find? Find two numbers, right? So what can we declare? Let x equal one original number. Let y equal second original number. Okay, so now I know what my x and my y stand for. So it tells me the numbers are in the ratio 6 to 11. In other words, x, remember ratio is just another way to say fraction. So x is to y as 6 is to 11. Okay. What does that mean? Well, that means, one thing that means is x is the smaller number. That matters. But if we take the first number, what I called x, and decrease it by 4, and the second number, what I called y, and increase it by 6, the resulting numbers are in the ratio of 4 to 9 equals 4/9. Okay, so one of the things that you should know whenever you have two fractions that equal each other, you can cross multiply. In other words, 11 times x equals 6 times y. Right? So you can do the same thing over here, cross multiply. You got two equations, two variables. you can solve. Okay, so that got that problem set up for you. All right, the other problems then, number 2 on either page 181 or 175, that's a word problem, and looks like it's going to be a little bit similar to that number 7 right there. There's a ratio involved. And then the other one is number 14 on either page 182 or 176. And that's one of those solution problems, or what I call quality quantity problems. Okay, so I think you'll be good there. All right, there's your assignment. There's a little bit of help on how to do those problems. So I hope that works out for you. Enjoy the assignment.